Hi, ladies and gents. We're going to continue with our concentration calculations, and this time we're going to talk about percent volume and percent mass volume. But we're going to begin with percent volume calculations. Now, this is really useful when you're talking about a liquid dissolved in a liquid, and the situations where you're going to see this very often are alcoholic beverages, antifreeze, and milk. So let's talk about one of my favorite beverages on the planet, milk. When you go to the grocery store, milk can be purchased in 2%, 1%, and whole milk. Now, whole milk is 4% milk. And if you've ever wondered what in the world does that mean, that is the percent butter fat in milk. And if you're dealing with whole milk is 4% butter fat compared to the entire solution of milk. 2% milk is half of the butter fat has been removed. So you are now down to half of the fat content of whole milk. It doesn't taste as luscious, but you don't have those extra fat calories. What do they do with the removed butter fat? Well, they make butter and ice cream and other really lovely, luscious things out of it. 1% milk, 3/4 of the fat content of the milk has been removed. And skim milk, all of that butter fat has been removed. How do they get it to stay contained and not separate out into layers? Well, it has been agitated to a point so that it is emulsified. And by emulsifying it, you don't get the butterfat staying on the top of the milk as a separate layer from the rest of the milk layer. But the other place you see this is in alcoholic beverages. So for example, beer, and all of these have a range, depends upon the brewer and the person making the beverages. So these are kind of generic numbers. But regular beer, somewhere between 4 to 6% alcohol is pretty typical. A malt liquor is going to be a stronger percent alcohol. Wine, 11, 12% alcohol is pretty typical. Brandy is going to be a higher percentage alcohol. 80 proof liquor is 40% alcohol. 100 proof liquor is 50% alcohol. Something like an Everclear is 200 proof. If you ever find 200 proof liquor, you are dealing with 100% ethanol. And that is how that numbers between proof and percent concentration of the alcohol content works. This is the equation we're going to use. Same format as that percent mass calculation. Volume of solute, volume of the entire solution times 100 to make it a percentage. So let's do a calculation using champagne, which you may not drink very often, but the same calculation could be done for beer, wine, or anything else. So a champagne bottle contains 750 milliliters. The champagne is 11% alcohol by volume. How many milliliters of alcohol are in the bottle? This is a little bit more complex than we did in our percent mass because I want to take you to that next level of calculation. So let's first look at this entire formula and let's kind of solve it for what we're looking for. This time we are looking for the alcohol. Now the alcohol is my solute. That is this thing being dissolved. So I'm going to do a little algebra. If you're reasonably good at algebra, follow along because I'm sure you can do this with me. If algebra is not your superpower, then follow along, and then when we come up with a answer, make sure you write this down. So my percent volume is going to be my solute divided by my solution times 100. And I want to solve for my solute. So the first thing I am going to do, and I'm going to change color here so you can see what I'm up to. First thing I'm going to do is I want to get rid of that 100. So I'm going to divide both sides by 100. And when I divide both sides by 100, it's going to get rid of it on the right-hand side. And then the next thing I'm going to do to get solute alone is I'm going to multiply both sides by solution. that concentration, the quantity of solution. This time it's going to be in milliliters, so I'm going to multiply both sides by quantity of solution. So let me pretty this up because right now it's kind of messy looking. So the amount of solution I am going to end up with, oops, I said that wrong. The amount of solute I'm going to end up with is going to be equal to the amount of solution I have times my percent concentration divided by 100. So if you are faced with a calculation like this, and you will be on the study guide, on the quiz, you can use this equation. So now that we have this equation, let's go back and let's use it. So I want to know my solute, how much alcohol I have. So to find out how much alcohol I have, I'm going to take the quantity of solution I have. How much solution do I have? I have 750 milliliters of champagne in a typical, and that is what a typical wine or champagne bottle is, 750 milliliters. By concentration, champagne, a lot of wines are about 11-12%. So 11% is this particular kind of champagne. And the 100 is what changes it from a decimal to a percentage. When I do this, when I take 750 times 11 divided by 100, and I throw this through a calculator, I get an answer of, I'm looking on my page where I did this earlier, can't find my number, so I'm going to pick up my calculator to make sure I'm not messing this up for you. Times 11 divided by 100, and I got 82.5 milliliters of ethanol, which is that ethyl alcohol, which is the alcohol people consume. That is how much ethanol is in one bottle of champagne. All right, let's do another one. Okay, I have 80 proof liquor. 80 proof liquor is 40%, and most of the liquor that you buy in the liquor store is going to be 80 proof. That means it's 40% volume solution. One shot in the US is typically 44 milliliters. If you read on the internet, there's going to be debate how big a shot is, but we're going to use 44. That's the most common standard. And how many milliliters of ethanol are in one shot? Now, again, I'm looking for my solute. So my solute is going to be equal to, let's go back and look at our equation, make sure we have this right. My solute is going to be my entire solution times my percent concentration divided by 100. So my solute is going to be my entire solution, how much solution I have, times my percent concentration divided by 100. So the entire concentration I have is 44 milliliters. That's the shot, one shot of liquor. Concentration is 40%. Why did I even mention the 80 proof? Just for familiarity for you, because that's how you may have heard of it in your life. And let's do the math. I'm going to grab a calculator. 44 times 40 divided by 100. So that is 17.6 milliliters of ethanol, ethyl alcohol per shot of liquor. Now let's kind of connect this and the last slide. 17.6 milliliters of ethanol per shot. Let's go back to a bottle of wine or a bottle of champagne. So let's say great Aunt Sadie gets a little tipsy and she drinks an entire bottle of champagne. How much is that? Well, if that's 82.5 milliliters of ethanol in one bottle, how many mixed drinks is that equal to, or how many shots is that equal to? If I take 82.5 milliliters and divide that by 17.6, 82.5 divided by 17.6, that's equivalent to 4.7 shots, or not quite 5 mixed drinks, or not quite equivalent to 5 beers. Yes, your great Aunt Sadie, if she drinks the entire bottle of champagne, she's going to be a little tipsy. So yeah, just yeah. All right, let's do something that is a little bit different. this is the similar calculation. You're going to notice all of these equations look very much the same. Mass of solute divided by volume of solution. So if we look at, for example, this betadine medication, this is a throat lozenge, this is a weight volume, and is what is recorded on it. A saline solution is a solid dissolved in a liquid. So sometimes you're going to hear this recorded or reported as a weight volume. Physics, we really care a lot about the difference between mass and weight. Chemists are a little lackadaisical about that difference between mass and weight. But it is mass of solute in the entire volume of solution. So let's go ahead and do one of these. A standard IV bag contains 500 milliliters of volume. If the IV solution is 0.09%, how many grams of sodium chloride are in the bag? All right, so my solute is what I'm looking for. That's my sodium chloride. That's going to be my entire solution times my percentage divided by 100. So my entire solution is 500 milliliters. The percentage is 0.9 and divided by 100. So I'm going to throw that in the calculator. 500 times 0.9 divided by 100, and I end up with 4.5 grams. Now you might look at this and go, Mary, the units don't work because these are milliliters. Magically grams appear. Yeah, it bothers me too, but that is the way the mathematics for this works, because you are solving for mass of solute in a volume of solution in milliliters. Yeah, trust me, it does work, but it looks mathematically a little funny. Okay, make sure you write this equation down so you're prepped for the study guide and the quiz. See you later, alligators, and we'll come back and we'll do some more of another kind later. Bye-bye.